Welcome to another Domo Lunch and Learn live stream. We're back this week after being off for Domopalooza. Had a fantastic session on Tuesday. If you didn't get a chance to see that, go back into wherever you get your live streams for the Domo Lunch and Learns and watch Ben Shine talk about all the fantastic stuff that we did and released during Domopalooza this year. In this live stream, however, as is every Thursday's first Thursday of the month live stream with our data science team taking over this lunch and learn, as they're going to teach you all about forecasting, which is a powerful and popular statistical technique inside of our business analytic tool, what it is, when you should use it, what data you might need. They're going to walk you through all kinds of various techniques and tools to visualize those results, which we're really excited about. We have a huge audience already joining us, which is fantastic. Don't get nervous, Flo or Steven or Brian from our data science team. Thank you guys so much for joining as always. I truly do appreciate it. And for those of you that have stepped away from watching your master's live stream to here, we greatly appreciate you being here. Obviously, make any comments, questions, suggestions, feedback that you have for Flo, Steven, and Brian in the comments and live chat section of this live stream. But at this point, I get out of the way and I let Flo, Steven, and Brian take you from here as they talk about forecasting and Domo. Thank you guys so much for being on the live stream this week.
No, thank you. We're excited to be back and excited to have a huge audience. I don't know what huge means, but we'll take it.
It's big. It's big.
It's big?
Yeah.
Like how
that's
big?
What we use. That's the statistical data term, right? That these business analytics folks use. It's huge. Wait till you see the number.
Huge.
I'm not going to tell you what it is. It's big.
Okay, good. I feel like that makes me feel better. I don't want to know the exact number.
Fantastic.
All right. We'll run through some brief introductions so the huge audience knows who we are. I'm Flo. I'm a data scientist on the Domo Data Science Professional Services team. And I am excited to be here. I'm excited to be here every Thursday. And I did come on Tuesday to Ben Shines. So I guess I come here pretty frequently. But now I get to be on this end of things. So that's fun. So I'll let Steven and Brian introduce themselves as well.
Awesome. So I'm Steven Gatron. I'm a senior data scientist on this team. I'm really excited to be here, share some concepts with you all. And yeah, so looking forward to this.
Awesome. Yeah, hey, I'm Brian Powell. I'm an associate data scientist on our professional services data science team here at Domo. So also very excited to dive in on forecasting and crystal balls here with you guys.
All right. So with that, I will get out of the way. Flo, you're in charge. Anything that happens technically is done by, what do they say, the wizard behind the curtain, which will be me, because you don't need to stare at my face for the next 30 or 40 minutes. But again, guys, thanks for showing up. Again, if you have questions or comments, or just let us know where you're joining from, put those in the live chat section or the comment section, wherever you may be watching this Domo Lunch and Learn. Thanks again, guys. Really appreciate it.
Thanks, Eddie. All right. So I will be sharing my screen here first. We're going to go over some slides that talk about forecasting, what data for forecasting should look like, when it's beneficial, when it's useful, and then we will go into some live demos of how to do forecasting in Domo using different tools. So with that, I will share. If I do this, can you still see everything?
Yep, all set.
Yep.
Awesome. Okay. So like we said, we're the Domo Data Science Professional Services team. Not everyone could be here today, but we are all very excited to be involved in these lunch and learns. We love to share our love for data science with anyone who will listen. So just a brief overview of what is forecasting. Forecasting is really predicting future outcomes, or this crystal ball that Brian talked about, using historical data. And specifically for today, we're focusing on univariate forecasting, which is really using historical data for a single variable and predicting that variable in the future, right? So it would be something like using revenue and revenue only to predict future revenue. Here we have an example of customer orders by month. We're not considering other features or factors and how they may influence customer orders. In this case, we are just looking at the past for customer orders and predicting the future based on that. why do we do this? Why do we use past data to predict the future? Isn't the future to some extent, unpredictable? The truth is that most data, when we look at most data, the future often looks like the past. And as we train models and we test the models and we build ways to evaluate the accuracy of the models and the predictions, we see that this is very true for a lot of data, not for every kind of data, but for a lot of data. So for example, for total employment in US retail, there's always these peaks around the holidays, right? In December, or starting with like Black Friday usually, companies are trying to hire more people to meet the demand. So that there's this trend that we can predict. So we tend to see, in this case with retail employment, the same pattern over and over again. So this showcases different components of historical data that indicate that this is a good data set for forecasting. So the first thing we see here is that there is a trend. We call this a trend cycle, and this trend cycle just indicates whether, generally speaking, the data is, has an increase or a decrease or is relatively flat. The second component is the seasonality that we talked about, right? Around the end of the year, every year, we have this peak. This is called seasonality. And the last thing is error/noise. There's just some things we cannot account for in the model. There's just variation that we can't predict. COVID was a huge one, right? But it can also, I don't know, I'm trying to think of an example with total employment in US retail, for example. If like a huge video game is coming out one year, maybe GameStop needs to hire more people than they did last year. And that we can't really account for. So that would be captured by error. So we look into the future using the components that we just talked about, looking at the general trend, looking at seasonality, and accounting for the error that the algorithm can implement. So these are the three things that forecasting takes into account. And with that, we can kind of, as you can see with this purple squiggly line, that's kind of what the forecast would be. It's based on these three components of the forecasting algorithm. So what can we get from a forecasting model? What we can get is a prediction interval. So as you can see here with the shaded area, we are pretty confident when we can talk about intervals in more detail, but we're trying to keep this pretty high level. We can say with confidence that most of the time our prediction will be between these two values. That's what the gray shaded area represents. We can also get the point estimate, the exact value that the forecast indicates would be the future prediction. We can also decide how far out we go into the future, right? So we could predict the next 2 months. We could also predict the next 24 months. But the farther out we go, the less certain we will be in our forecast. So that's kind of expected, right? So what kind of outcomes can be forecasted? If you have a question about whether or not your specific data set or use case can be forecasted, throw it in the chat. And maybe while I'm doing this, Stephen and Brian can just look at it and see if they can answer that question. But so anything that can be observed sequentially over time and has a strong pattern. So something that doesn't have a pattern is going to be really difficult to forecast. It can be forecasted. It's just that it won't be a super accurate prediction, right? So some things that we can predict: annual company revenue. We tend to, if there's enough data, we can usually see some trends and some seasonality patterns that we can forecast. Quarterly customer purchase amounts, weekly course enrollment, daily resort attendance. What we cannot predict are random events. If there's absolutely no pattern over time, if there's no logic to the trend or to the pattern, then it's not something that can be accurately forecasted. Again, we can put it through the model and the model will kick off a number, but the reliability of that number is a different story, right? So something like winning lottery numbers or predicting fashion trends or predicting natural disasters or something like COVID, that's just not something that we can forecast. So what data do we need in order to forecast? And again, we're talking about univariate forecasting. So we are just using past values of the outcome that we want to predict in order to forecast. So we need data that is sequential. So we need the data to be observed at the exact same interval. So this would be weekly data, monthly data, daily data. It just has to be recorded consistently at the same interval. So in this case, we have an example of monthly data and a random outcome. It could be anything we want, but it's recorded sequentially. The format traditionally is one column with the time variable and one column with the outcome variable. And I guess we're limiting our forecast to this one predictor, which is what we're also going to predict as the outcome. So that's why we don't need, 20 columns for this forecast. We also cannot have a lot of missing data. Missing data is really difficult to work with, especially when we're doing a univariate forecast, just because this column is the only thing we're using to predict the future other than the seasonality of the months. And so if we have a lot of missing data, the model is not gonna perform well. If it performs at all, it may just say that there's an error, right? And another thing to remember is that we predict the outcome at the same granularity at which the previous data was collected. So if we have monthly data, as we do here, our predictions will be at the monthly level. We can't predict at the weekly level. We can't predict at the yearly level. It has to be in the same granularity as the previous data collection measures. So your data needs to be plentiful in the sense that we need to have enough historical data to capture seasonality. So if we only have 18 months of data and we want to look into the future, we can't capture seasonality because we don't even have 2 data points per month. We may not have 2 Decembers or 2 Julys. So we need to have enough data going back. Let's see. Well, here's an example. Not enough data to capture the yearly trends, right? The more data, the better. That is, in data science, kind of the first pass at how much, with the question of how much data do you need. The more data, the better. We can always build in logic to filter out historical data. We can implement cutoffs based on exploratory data analysis, based on any business logic. But the more data we have to start off with, the better off we are. So with that, we are going to showcase 4 different ways of forecasting in Domo. We are first going to show you how to quote unquote forecast. They're really called projections, but it's really like a forecasting idea using Analyzer and line charts. This is available to all customers. It's very easy. You don't need to have any access to premium features. So in that way, it's accessible to everybody. And it does the underlying algorithm is linear regression. So we'll go over that one first. Then we will show you how to use the forecasting tile in Magic ETL. This is a premium feature, and it is a very powerful tool. If you don't want to code a lot, it does run on the ARIMA algorithm, which is actually one of our, I won't speak for other people, but I personally use it a lot for customer solutions, this ARIMA algorithm. We will then look at AutoML, which is, again, another premium feature, so not available to everybody. This tool will run through different types of algorithms and indicate which one is the best fitting for your data. And that can then be automated to run in ETL. And then Brian's going to walk us through Jupyter Workspaces, which is our bread and butter. We love Jupyter Workspaces, especially for being able to customize a forecast and to quickly evaluate how well a forecast is performing. So with that, I will switch screens. I'll stop sharing here. And I will switch over. I am technologically capable of switching screens. Okay, let's see. Here we go. All right, so the first thing we're going to show you is how to create a card and how to do this in Analyzer. So that we're going to select our existing data. In this case, we have this input data set, and I will show you what the data looks like. You'll see that it matches pretty well with what we saw in the in the slides. So when we look at our data here, we have month level data and then the sales in millions amount. The data goes back pretty far. It goes back to the 90s. We probably don't want to use absolutely everything, but you know, it's pretty hefty data. We don't have a shortage of data for this. So we're going to go back to visualize. And what we're going to do here is we're going to create a line chart in which we have month. Let me remove this because that's not super relevant to us right now. And we're going to limit the data to, let's say we're interested in the last, 5 years. And let's do 10 years. And we want to graph it by month. So here, it's a lot of data, right? Here we see this seasonality, right? We see that around November and then definitely December, we have this huge peak of sales. Makes sense. It's a clothing retail store. People like to go shopping at the end of the year, especially if a company has really good sales. Here we see this nasty COVID time period that doesn't look anything like the rest of the years. So what we're going to do here is we're going to use the projection option here. So under the properties for the chart, we have this multi-period projection. And with this, we can say how many time periods into the future we want to predict. So since it's at the monthly level and I'm interested in the next year, we're going to predict the next 12 observations. And we want to predict the next 12 because, again, we have monthly data. Now you can select which type of equation you want to use. They're all based on linear regression, but they emphasize different things. So basic linear regression is not going to look too great right here. But when we select a different option, linear regression by period, this will capture seasonality to some extent. So you can see that the peaks are a lot smaller, but there are peaks around the end of the year. We can also do linear regression focusing on recent periods. So see how this peak matches the most recent period. So in this case, it's not capturing seasonality as well, but it is copying essentially the previous pattern that it saw. And the last one is linear regression, recently weighted, and it looks a little weird. So it's not you can't customize it at all. We'll just put it that way. It's good for like a very rudimentary prediction, and we can put here repeating pattern. I forgot to do that first. This repeating pattern will capture seasonality. So we're putting repeating pattern as 12 because the timestamp of month repeats itself every 12 observations, right? So we have January, and then 12 observations later, we have January again. So that's the repeating pattern. So when we do that, this figure matches a lot more with the previous years, right? Again, you can't customize it a lot. You also can't, like this does, the values that are predicted here don't show up anywhere in your data table just because they're projections. They're not in the data that is being used. And so you can't really, you would have to hover over each value and write it down. And that's how you would, use the projections, but not super straightforward for using it in other environments. But it is available to everyone, and it is a really quick way of just projecting or forecasting into the future. Option number 1, not our favorite, but it's there. We then can do forecasting in Magic ETL. So I already built the ETL, but I'll walk you through what it includes. And it's really straightforward. Again, this is a premium feature. So we have the scripting and data science tiles here. Those are added data science tools. So if you want access to these, it's something to talk to a CSM or AE about. You won't find these in your instance unless you have a deal to use them. So here again, we have the same data set that we had before. We have the month and sales in millions. The filter rows option is really helpful if we want to exclude a certain historical time frame. In this case, I'm only interested in using the last 5 years of data because imagine that the years before those 5 years looked a little funky, so I don't want to include them. That's what this allows you to do. And then we have the forecasting tile. It's really straightforward, no code required. So if coding is really not your thing and you want to forecast something, this tool is really, really helpful. But we first select the column that contains the time. So in this case, it was month. We also select the column that we want to forecast. So this is the historical data that will be pulled in to predict the future. Then we want the prediction bands. This was the gray area. And this is when we want to say, you know, that 90, in this case, we have 95, right? That's pretty standard. It's the default. And this just means that if we were to run the forecast 100 times, 95 of those times, the value would absolutely fall within the upper and lower bounds that we're calculating. So that gray shaded area, in case you want some statistical knowledge on the side. How many dates do we want to predict? Again, we want to predict 12 because we just want to look into the next year, the next full year. How many preceding rows should be considered when scoring each row? This allows you really to weigh more recent observations more heavily than previous ones. So if I were to say, you know, 50, it would just look at the previous 50 rows and weigh the rows before that lower. We then just name the column that will store the forecasted value. So this is the point estimate, right? Like the actual value that we're predicting. And then we name the upper and lower bounds. And this is what allows us to create that shaded area around our point estimates. And then the last option is to indicate the seasonality, basically, right? So in our case, our data, again, repeats itself every 12 observations. So that's why we have the value of 12. If our data was weekly, we would say, if it was daily, we would say 7, just because that's how frequently it repeats itself. So it's pretty customizable, and it runs on AutoArima. That's the underlying algorithm. It actually uses R's AutoArima package. So it selects the best parameters for the data and it applies those parameters to the prediction. So when I already ran this, so I can just show you what the output looks like here. And then we will go ahead and just show you how to graph it really quick. Let's just look at the data set. Time flies when you're having fun. So here we have, for historical data, you'll see that it created all these columns, these 3 columns for the predicted company sales, which is, again, the point estimate, and then the upper and lower bounds. We're not going to predict this for historical data. But when we get down to the next 12 months, so starting April 2023, we don't have an observed value for sales in millions. We have our prediction, and then we have our upper and lower bounds. So what we're going to do is we are going to go to Analyzer. And we are going to use as one of the data science chart types. Let's see, the forecasting chart. And what we're going to do here is we are going to graph this by not year, but by month. I always find it so funny when figures look like that. Okay, that's more like what we want. Here it automatically loaded the forecast. Here we see it in a different color. This is the prediction. And then we can add the upper and lower bounds. Is this lower bound right here? Wait. Should be using a mouse instead of my mouse pad. But here we have, you see, as we get farther out into the future, we are less confident in our point estimate, which is why the bands get wider as time goes by. So the forecasting tile does give you these upper and lower bounds that make people feel more comfortable showcasing this to executives at a company, right? Like no one wants to say, you know, we predicted 34,350,000 million sales, and then you're off by like a few numbers. Like if you have these bands, people just feel a lot more comfortable with the prediction. So that's the forecasting tile. And the last one I will talk about is AutoML. So for AutoML, let me pull up the right data. AutoML runs, well, dozens of models for you and tells you which one is the best fit for your data. So we have here our input data. AutoML does require 500 rows of data. And so this data set goes farther back. It goes to into the 80s, not just the 90s. And for this data set, for AutoML to run properly and to be able to implement it into an ETL, we have to have the future dates as well, just the blank revenue. We don't know the actual revenue for any of these months. So we just create the date rows and just leave them blank. And then we click on this AutoML thing up here. I already ran the model, but normally I can just do this and you'll see the original screen. When you select AutoML, you can set up and configure your machine learning to match your needs. So the column I want to predict, of course, is revenue. And task type, you can select here automatic, which will let AutoML run different types of models and see which one's the best fit. However, I know that my outcome is numerical. I know it's a continuous variable, it's money. So I know it's not going to be binary classification and it's not going to be a multi-class classification. Maybe if I wanted to break my revenue up into, 5 buckets every like 5,000 or something, then I could do a multi-class classification. But regression is really our option. And it even says revenue as the example. So that one is kind of an easy one. But if your outcome is a continuous variable, regression is the way to go here. And then you can select how many models you want tested, right? You can go fast and that will test fewer models, or you can let AutoML take longer, which will run more models, but it will also be more accurate. Then you select start training. And once you have trained your model, this is what you'll get. And here you can kind of examine the different models that were tested. So in this candidate test results, you can just expand this table. These were all the models that were ran. It tells you the model type. It tells you the MSE, which is for regression, the type of parameter that we evaluate to decide whether or not the model is a good fit. And it tells us here that model 3 is the best fit. So assuming that this is right, we would just select deploy to ETL. And it will automatically have this AutoML inference, which I believe is a data science. Yep, data science. Again, so there's a premium feature. It's a data science tile. And you can select, if I were to change this data set out and pull in a different data set for which I had ran AutoML previously, it would show me all the models associated with that inference for that data set. So once we have this, we just, have an output data set and run it. And this is what the data will look like. Let me pull it up. So let's see, I don't know. Here we go. When we look at our output data here, we'll have this new row of revenue prediction. This is what the model produced. And of course, we don't really care about the prediction for previous months, but for the most part, it's not super far off, right? It's a pretty close prediction. But when we look at our future data, let me scroll all the way down. Starting in April of 2023, we don't have observed revenue yet, but we do have the prediction. So with this, we would be able to go back into Analyzer and build a chart that showcases this. Now, AutoML doesn't give you the lower and upper bounds that you get from the forecasting tile, but it does allow you to consider different models. So there's pros and cons to each of the tools. There's we use different tools for different situations, but what we try to use more than anything is Jupyter. And Brian here is going to show you how to forecast using Jupyter workspaces. And again, we love Jupyter. Jupyter is, you know, not only our favorite tool, but it's what we try to get customers to use, just because it allows for so much more I can't never say that word, customizability. I don't know if that's close enough. You get the message. So Brian, show them the good stuff now.
Let's do it. Thanks a lot, Flo. And yeah, Flo's done an awesome job highlighting a lot of fantastic tools in Domo that you can use. I think that's one of the best parts of Domo, is that you can come as you are, and there's plenty of low code, no code environments that you can come into with Domo and still be able to apply what you do know to be able to execute data science and data analytics goals.
Like Brian, before you get started,
yes.
Our friend Dan, oh boy, it's good to stop notifications when you're on live streams. That should never happen. So our good friend Dan on YouTube, love the picture, by the way. How wide can the data be for AutoML? Do I need to really do a good job of summarizing my data before running it through the models? Uh-oh, Flo, she's muted. Let me unmute her.
There we go.
Okay. The question is basically, how many columns can you have, right?
Okay.
At this point. Steven, do you have an answer to that? I would have to look because I haven't tested it.
I think you need to look, but I would say that I think it's always good to just kind of feed it because it's AutoML, right? You think you can feed it anything and it'll kind of spit out a result. But I think like it's like a lot of the auto AI tools today, the prompts that you give it or the data that you give it, if it's much more clean, I think that you're going to get more concise, better results. So, if you're going to do something like forecasting, probably feeding in something where it's clean, exactly like Flo showed, where it's very nice, like a date and sales and whatnot, that'd probably be the best.
Awesome. Thank you for answering that.
Best
Dan
practices.
says yes.
Yep. And this
Hello,
counts for not just forecasting. So
love it. All right,
yeah,
Brian,
I really
you're
like
up.
your photo, by the way. Random.
As Dan says,
Thank
thanks.
you. Perfect. All right, let's get that shared back up again. Here we go. Good deal. So yeah, again, diving into Jupyter, like Flo said, this, as a data science team, I would say is our favorite tool in Domo for data science. You're not supposed to have favorite children, but we do absolutely love Jupyter Workspace for data science. It's something that we are able to use on its own as a standalone tool. You can use it as a data flow option, and you can schedule it to run and have output data sets. It's just a really versatile tool, but you can also use it in conjunction with Magic ETL and some of these other tools that Flo's already shown. The way that we would use it in conjunction with Magic ETL is we use Jupyter Workspace as kind of a sandbox where we'll do a lot of the development of our models. We'll do a lot of exploration. It's a really efficient tool for putting in some of this code either in R or Python and kind of exploring the data we have, making changes we need. And then once you've refined that code, you can put that into some of those scripting tiles if you prefer having that low code environment or no code environment for the kind of data manipulation with the SQL tiles, things like that we have there. So Jupyter, again, is just really versatile. So we love it. And we use it in every solution that we create here at Domo. But what we're going to focus on here is similar to what Flo's already shown you in these other tools, is kind of doing an aggregate forecast here in Jupyter. So I've done this in R. And let me jump back out just so that I can show the configuration of a workspace here. So we would jump over to this data tab. And then down here, if it is a feature that you've upgraded to, you'll have Jupyter Workspaces show up in these 3 dots at the bottom. Specifically, I'm working with this Lunch and Learn aggregate forecasting workspace. And you can see I've got this wrench here that you'll see all across Domo. With a workspace, you can enable sharing for this so that you can actually work on this with another analyst potentially. You can edit the workspace setup here. You can see I've got like the name set up here. With the workspace configuration, you determine whether you're going to code in R or Python. The Jupyter Workspace is actually charged on a usage basis. So you don't have to pay hundreds of thousands of dollars to get access to this tool. It's something that'll be charged on a usage basis. So even if you're going to use it a little bit or you're trying to get familiar with coding, you actually can use this as a pretty good resource for that without going super deep into your pockets for it. So right here, you choose the tier that you're going to compute with. If you have a lot of data, maybe you need a higher compute tier to be able to handle that. And then it will time out. You can set it to time out at 1 hour if you're not working with a lot of data that's going to run for a long time, so that you keep that usage down. Moving forward, I've put in the input data set I'm going to use in Jupyter Workspace. It's the one that Flo has already shown you that goes back to 1990 on a monthly basis, showing us the sales for a retail clothing store going back that far. And then jumping up here, I've also told it, and at this point, so with the input data set, you'll search and you'll find the data set that exists in Domo or you've put into Domo already. With the output data set, you add an output data set and you actually physically name that at this point as you're configuring your workspace. So I've done that already. I've got this Lunch and Learn aggregate forecast output that's going to be the output data set from our workspace here. All right, so now that we've done all the dirty work with the configuration there, we can dive into the fun stuff here with the coding and kind of exploring our data. So again, we're coding in R here. And so I've extracted all of the libraries that I need to be able to do this forecasting. We've taken that input data set, which you'll find in this data section of the Jupyter Workspace and input data sets. It's as simple as clicking on that, and it will give you a cell with all the code you need to input that data set. And the same goes for that output data set. It'll write that code for you if you double click on this output data set at the end of your script here. But what we're going to go through here, we've got that input data set in, and here I've switched that over to a time series so that we can use it for forecasting. So you can see this is the structure of the data set as it was input. When you switch it to the time series format, it's going to look like this. Since it's monthly data and we're looking forward in about a 30-year span here, we've got these first 3 years laid out in that time series format. So if we jump down to the next step, we're going to plot and decompose that data. So with that plot, we can see that history that Flo's already shown us. We've got a huge cavern here for COVID on sales. If we jump down to the decomposition, this also is something that was covered by Flo that was really interesting. Oh, that's lovely, and we're gonna have to restart that.
Hey, Brian. Sorry, Brian. Brian,
go ahead. Yes.
This is what I never love about this platform. I have covered up our good friend Steven, who's got a few times to chime in here. But Dan had another question. I wanted to ask it real quick. How is, because you were just talking about Jupyter, how is usage charged for the Jupyter space, amount processed, time processed? Could you give him a little more insight on that?
Yeah, I don't have the exact figures on that myself. Do we, Stephen or Flo, do we have that available for us here, or do we want to maybe circle back to that or have a resource like a link that maybe we could add to the chat later on here?
I would think it's something to talk to your CSM and AE about, like the exact figures. Yes. I don't think we don't really deal with that. We just use Jupyter.
Right. Yep.
So, awesome. Steven, I don't know if you have more information there, but
I mean, generally, like if you use more computing resources, it'll use more of the credits, right? It's very, right. And I think practically the best thing to do is just, run it. You can run it on a smaller tier, see if it is satisfactory to you. And then if it, if you find that you're kind of timing out, or maybe you want it to run kind of quicker, just keep kind of moving up and see how it fits with your workflow.
Appreciate it. All right, back to you, Brian.
Perfect. Thanks. All right, good deal. Yeah, so we can jump back here now that this is reloaded. That was actually the perfect time for a question. So if we break down again, That would be great if we keep those coming. But jumping back here again, we've plotted that historical data with the cavernous 2020 year there. And then as Flo pointed out earlier, there are three components to a univariate forecast. So we've got within this, we've been able to run a function to kind of decompose that. The top is just a repeat of that historical data. This portion is the trend that she was describing. So you can see that we've got a pretty solid upward trend. And then again, that cavern for 2020, but it returns back to that upward trend. We've got the seasonality component, and this is fantastic data for a univariate forecast because it has a very strong seasonal pattern over the span of each year on the monthly basis. And then finally, we've got that random chance or random noise that's going to exist in any kind of data science work that you do. With that random noise, however, it is best if that is balanced above and below zero as far as where that variation lies. And I know that I keep pointing out the 2020 COVID cavern that we have here, but that is just a big problem. I know it was a big problem for everybody's lives in general, but it has made forecasting and it has made data science in general a little bit more difficult as well. Now that we're removed from it a little bit, we, again, like I pointed out here, and I'll point it out later on as well, you can see that the trend kind of follows what was going on before COVID, which is really fortunate for forecasting, and I'll touch on that later. But again, it's also causing an issue with this variation maybe not being as balanced as we'd like. It kind of dips very hard on the low side here below zero. But if we were just going to, say that's all right, we're okay, and we've accepted the amount of variation and that deviation from what we expect, then we can move forward with that forecast. And so we've done AutoArima here to determine what parameters we want to use for our ARIMA forecast. From there, we've input those into an actual function for ARIMA so that we can actually execute that forecast. And then from there, we've got that, and we've specified, hey, I want to go 36 periods or 36 months, 3 years forward, and then plotted that. And within R, you're going to get this kind of interface here where you get that historical data, and then the forecast shows up in blue here at the end. So you can see that it's kind of a little bit of a dampened trend going forward. That's, again, because of that cavern there. So maybe we want to explore, hey, since that trend did seem to continue after the COVID anomaly there, maybe we can just do what everybody would have loved to do in general and delete COVID, both from our data and from our lives. We'll pretend it never happened and be really happy about that. But so that's what we're going to do for the forecast. Again, if there were, like, in 2021, just coming out of COVID, this was kind of an assumption that you could make. Maybe there were a couple of different paths things could have gone for sales going forward at that point. And I would then have suggested maybe creating a couple of different forecasts, maybe one that says COVID didn't happen, one with COVID, and then maybe one that's somewhere in between. But since we have a little bit of data after COVID that kind of shows that our hypothesis is right, that things return to normal, we're able to maybe go forward with that and say, hey, let's pretend it never happened. So we're going to do that here. We go through the same process we did. It's no longer there. There's no cavern. We do the decomposition. We've got a nice solid trend with no cavern. And this random noise is now completely random. There's no cavern that's really skewing that. So we're a lot more comfortable with what's going to happen going forward here. We run the same functions here to get our parameters and then execute on that and show a forecast. You can see that that has a bit more of an upward trend and follows that a little more strongly than the one that had COVID here, which doesn't follow that as strongly. So that's nice. In addition, I've done a calculation here, which, again, it's really efficient to be able to do all of this kind of sandbox work here in Jupyter Workspace. I'm able to then very quickly explore, okay, what exactly is the difference between my COVID and my COVID agnostic forecasts here. I've calculated the average difference, and it's only 1,213 units. Sounds big, but on the scale that we're working that on, that's only a 3% difference on average for each point that was forecasted. between these two forecasts. So we have improved the forecast as far as our logic is showing. But it's not such a vast difference that we're worried that maybe we're, deviating from something that COVID year may be telling us, right? So from there, last thing I'm going to do is I've selected the COVID agnostic forecast as my favorite one here. Now I'm going to format it so that it's ready to be used in a Domo forecasting card. You can see here that the output that your forecast is actually going to give you is this month. And then it's not going to give you the sales in millions, but it's going to give you these last 5 columns here. And these columns are going to be showing your forecasted sales and then your prediction bounds, like Flo was telling us about earlier. I've then added this sales in millions column with nulls because these are all future dates. The sales haven't actually happened yet, but we do need this column so that we can append this to the historical data. In turn, we now need to kind of switch up that historical data so that we have those forecasting columns represented as well. So I've created a bunch of null columns for that historical data set, and we've got those 5 now full with nulls, and we can do an appendage of these 2 different data frames, the historical and the forecasting. And you can see here now we've got a bunch of historical data, and now we've got the forecasting data all happy together in one. And that's the format that we're going to need so that we can create that forecasting card with the historical, the actual forecast, and then the prediction bounds. Finally, we've got this function right here at the end. Like I said, you can even as simply as coming back here and double clicking your output data set, it will write this code for you. And you run that and it will output it to a Domo data set. Now, like I said earlier, you can actually convert your Jupyter workspace to a data flow that can be scheduled. So I'll come up here, and I've already scheduled this, but you name the data flow, you give it the description you want, and down here, I've put it on a schedule to run on the 5th of every month. I expect that all of our sales data will be concrete, and our team that runs finance and things like that is going to have that concrete number for the month of April by the 5th day of that month. So we'll run this forecast once that's already finished. So once I schedule that, it spits it out as a Jupyter data flow. So this will show up in your data warehouse here with all the other data flows, and it gets a special orange icon here for Jupyter instead of that normal, the splitting data flow icon that you get in Domo. It's going to look very similar in the history here. When it does run, one nice thing is that it will create a folder here in Jupyter Workspace called Recent Executions. And each time this is executed, it's going to give you the output, and it's also going to give you a log of how this code ran, so that if this breaks, you can come back and say, okay, well, it ran on April 6th. Where are the errors in my code? So that's a really cool feature as well of this. Now, diving into the data, this is going to have that structure we saw. So just really quickly look at this. It's now in the Domo format and in a Domo data set. And you can see the forecast down here. Last thing is you've got your wonderful forecast all set up here in Domo now. And this is going to be the same card that Flo used earlier. You're going to go into the data science chart types here. And it will be the forecasting type. And again, you're going to put your month on the x-axis, get your actual sales, your historical sales in the y, put your forecast here, and then the lower and upper bounds for your predictions here. And yeah, so that is getting this all pulled together. You can see that this is a really long history that we've got here, like Flo mentioned earlier. So I can zoom in and say, okay, let's take a look at how it's looking on the last 5 years or so. And you've got those 3 years forecasted here. You've got the darker shading for your 80% prediction bound, and then the wider here for the 95%, along with this orange forecast. So
I love that you can have like multiple bands for like the upper and lower bounds. And you can calculate that other than in Jupyter. So that's really cool. But also Analyzer allows you to have both of those. So that's so nice.
Agreed. Really cool feature, because perfect world, your forecast is going to fall exactly on that orange line, but that's probably never going to happen, right?
Yeah.
So,
and if it
so
does, it's probably random.
very random, right? So yes, you're more comfortable saying it's going to fall within these bounds somewhere, right? And like you said, Flo, you can put multiple bounds to say, hey, we think it'll fall in here, but there's a possibility it could fall out here, right? So that's really cool. But yeah, I think that's all I've got on Jupyter Workspaces there, Flo.
Thank you so much, Brian.
Yeah.
Awesome. Well, I really hope everyone uses forecasting. I hope everyone loves Jupyter as much as we do. We're a bunch of nerds, but come join us.
We're joined by a bunch of nerds. Listen, this was created really quick. Flo's going to go, oh, this is the first time I've seen this. Our community virtual meetup is happening on April 20th. If you have not registered, check your email or check, I'm doing it right now. I'm doing it on the fly. This is scary. Or check the chat for the direct registration link. Obviously, lots of your friends and data nerds have decided to come to these community virtual meetups where our data science team will be taking it over this month to talk about how to create composite measures using data reduction techniques. Super excited to be joined by Christy, Shelby, and Florencia in that session. If you haven't, check the StreamYard link that is happening inside of the live chat. You can click that to directly register. But how about that? We've made it big time.
I will say, we have a really cool guest coming for that event too.
Special sneak peek.
She's a wonderful customer.
You won't want to miss it.
Yeah, you do not want to miss it.
Yeah,
she is one of my favorite, not only customer, but she's one of my favorite people.
Ooh.
I know.
That's good coming from you, Flo. All right, guys, really appreciate you joining us for another Domo Lunch and Learn. As always, you can check the session out on demand. Go back and watch previous sessions. Most of them are on YouTube, or you can find them on our community events page in the new community forums, which we'll be chatting about very soon on possibly a future Lunch and Learn live stream. Thank you, Brian. Thank you, Stephen. And thank you, Florencia. Really do appreciate you guys being a part today.
Thanks, everyone.
Thank you.
Thanks, Eddie.
Bye.